Suppose that Sharon takes out a loan of $45,000 and agrees to make payments of $570 at the beginning of every other week. If the agreed upon interest rate is 2.5% compounded biweekly, how long will it take her to pay the loan down to $12,000? Since this question is an annuities due, since we know the payments are happening at the beginning of every other week, I'm going to choose to use the calculator here because it can be a little bit complicated to apply some of these annuities due formulas. In this case, Sharon's going to take out a loan of $45,000. So that money is going to come to her initially. And then at the end of this time period, we still actually owe $12,000. Let's take our future value to be $12,000. We are going to be making payments of $570. So let's input those payments in as negative $570. These are happening at the beginning of every other week. They are bi-weekly, so we have 26 payments per year. The last thing we need is the interest rate. We have 2.5% compounded bi-weekly. So with this information, we should be able to use our calculator to find N. So let's begin actually at our interest rate of 2.5%, and then let's go into the submenu, make sure that our PY and CY are programmed in both as 26. We can then input our PV of 45,000, our payment size of 570 negative, and then finally the future owing amount of $12,000. We can now ask the calculator to compute N, or the number of equal-sized payments we expect to have. So N here is going to come out to be about 60.8. We're going to round that up to 61 equal-sized payments. And in order to find the term, or how long it's going to take her to pay the loan down, we're going to take our N is equal to 61, and we need to solve for T. So how often are we making these equal-sized payments? Well, we're making them in a bi-weekly fashion. So F here is equal to 26. This implies if we want to know the length of the term, we should take 61 and divide by 26. And doing that, rounding to 2 decimal places, we get that the length is going to be about 2.35 years.